In this topic, we will learn about chemical hazards and safety. At the end of this topic, you should be able to describe globally harmonized system of classification and labeling, list the main types of chemical hazards in the laboratory. You should be able to state the key information and to identify the precautionary measures and emergency responses for chemical hazards using the safety data sheet. You should be able to describe the proper handling, including the general storage requirements and the risk control measures for the chemical hazards. And you should be able to perform proper handling of chemical hazards when working in the laboratory. So this topic will be broadly divided into two parts. In the first part, we will learn about the globally harmonized system of classification and labeling, which includes chemical hazard identification, safety data sheets, and chemical product labeling. In the second part, we are going to look at the proper handling of chemical hazards, including the proper storage, transport, and disposal of the chemicals, as well as the risk control measures. First of all, let us learn about the Globally Harmonized System, short form GHS. First of all, what is GHS about? It is a system developed by the United Nations for consistent chemical hazard communication. In other words, this is an internationally recognized framework for hazard communication across different countries. The purpose of having such a system is to protect the humans and environment against hazardous chemicals and also to facilitate international trading of the chemicals. This is because before such a system is being developed, different countries may have their own chemical hazard communication system, and some of the countries may not even have an existing system. Hence, when a country imports a chemical from another country, they may need to go through testing and also re-evaluation of the chemicals. Hence, having such an internationally recognized framework can also reduce the need for testing and evaluation of the chemicals. Singapore has started to fully implement the GHS system since July 2016. GHS ensures the standardization of chemical hazard communication between chemical suppliers and users. Under GHS, first of all, we will need to identify the chemical hazard through chemical hazard classification. Secondly, we will communicate the chemical hazard to the users through the use of safety data sheets and chemical product labeling. Next, we will take a look at the chemical hazard classification first. Chemical hazard is broadly divided into three types, namely physical hazard, health hazard, and environmental hazard. Depending on the property of hazard, each type of hazard is further classified into different hazard classes. Physical hazard has 16 hazard classes, health hazard has 10 hazard classes, and environmental hazard has 3 hazard classes. And depending on the severity of the hazard, each hazard is also assigned with a hazard category number. A lower category number indicates a more hazardous nature of the chemical. To assist with the chemical hazard classification, chemicals are assigned GHS pictograms. There are total 9 types of GHS pictograms. Each hazardous chemical can be assigned with more than one type of pictogram. This slide shows the 9 pictograms. We start from the top left-hand corner. A pictogram showing flame over circle represents oxidizers. A pictogram showing dead tree and fish represents environmental toxicity. A pictogram containing exploding bomb represents explosive substances. A pictogram showing skull and crossbones represents acute toxicity. A pictogram displaying a test tube pouring chemical onto the surface and hence represents corrosives. A pictogram containing the gas cylinder represents gases under pressure. A pictogram showing the human upper body represents toxicity to human. A pictogram showing flame represents flammable substances. And lastly, pictogram containing exclamation mark represents harmful substances. Physical hazard in general refers to the chemical substances which can cause combustion, fire, and explosion. These are the pictograms which are typically associated with physical hazard. They are oxidizer, explosive, corrosive, flammable, and gases under pressure. Under physical hazards, there are 16 hazard classes: oxidizing gases, liquids, and solids. In general, oxidizing agents can supply oxygen or to cause oxidation of other substances and lead to combustion. Explosive substances can cause explosion. Organic peroxides and self-reactive substances and mixtures are very unstable. They can undergo decomposition to release a lot of heat and even lead to explosion. Self-heating substances and mixtures can self-heat even without the supply of energy. They can ignite in large amounts and after long periods of time. Substances that are corrosive to metals can damage or destroy metals by chemical action. Flammable substances are capable of burning. Pyrophoric substances can ignite spontaneously within 5 minutes after coming in contact with the air. Substances and mixtures which in contact with water emit flammable gases means these substances are very reactive with water and can cause fire. And lastly, gases under pressure, for example, compressed gas, can also potentially lead to explosion if not handled properly. Health hazard means that the chemicals can cause harmful effects on human health. These are the 4 pictograms which are closely associated with health hazard. They are acute toxicity, harmful, corrosive, and toxicity. Under health hazards, they are further divided into 10 hazard classes. Acute toxicity means that the chemical will have short-term toxic effect on human. Respiratory sensitization means that the substance can lead to hypersensitivity of the airways following inhalation of the substance. Skin sensitization means that upon contact with the skin, the substance can cause allergic responses. The chemical substances can also cause skin corrosion or irritation or cause serious eye damage or eye irritation. Germ cell mutagenicity means that the chemical can cause mutation of the genes, and this will be transferred to the offsprings as well. Carcinogenicity means that the chemical can induce cancer or increase the chances of getting cancer. Reproductive toxicity means that the chemical can affect fertility in the male or the females. And this will also typically affect the offspring. The chemical can cause specific target organ toxicity through single exposure or repeated exposure. Aspiration hazard means that the chemical might cause severe acute effects, for example, chemical pneumonia or other respiratory problems. Lastly, environmental hazard refers to chemical substances which can have harmful effects on the environment. There are 2 pictograms associated with environmental hazard. They are harmful and environmental hazard. There are only 3 hazard classes, namely hazardous to the aquatic environment, acute toxicity, hazardous to the aquatic environment, chronic toxicity. meaning either the short-term or the long-term effect of the chemical on the environment. And lastly, hazardous to the ozone layer. After looking at how to classify the different types of chemical hazard, let us learn to communicate the chemical hazard to the users. First of all, let's look at the use of safety data sheets. All chemicals should have its own SDS, which is written by the manufacturer of the chemical. The SDS covers a wide range of information to ensure the safe handling of the chemical and the proper response in case of any accident. For chemical supplier, they need to provide updated SDS, typically within 5-year validity. It can either be in the form of a hard copy or soft copy. For people in charge of the chemical laboratory, upon receiving the chemical, they need to check that the SDS is valid and to perform risk assessment based on the SDS. And they also need to properly file the SDS. The SDS should be kept in the same lab where the chemical is being used. Users, before using the chemical, they should refer to the SDS for any precautionary measures that need to be taken. Now let us learn about the use of SDS by using sulfuric acid as an example. In this lesson folder, I have uploaded the SDS of 2 suppliers of sulfuric acid. Do note that even for the same chemical, different chemical supplier must issue its own SDS. I want you to pause this video and to visit the 2 documents of SDS and to answer the 3 questions. List the 16 sections in a SDS. Identify the GHS pictogram, signal word, and hazards associated with the use of sulfuric acid. What are the preventive measures to minimize the hazards associated with the use of sulfuric acid? An SDS document should contain 16 sections. Section 1 specifies the chemical name and composition. It also provides the supplier details and contact information. Section 2 is a very important section. It provides the hazard classification in the form of a GHS pictogram, precautionary statements, and safe handling methods. It also contains the signal word which indicates the relative hazard severity. There are only 2 words used in GHS. The signal word danger is used for more severe hazard, while the word warning is used for less severe hazard. Section 3 provides details on the chemical components and composition. Section 4 is another important section, which provides details on emergency risk response measures to be taken in the event of accident or chemical exposure. Section 5 provides information on suitable firefighting methods and other special hazards arising from the chemical. Section 6 details precautionary measures arising from accidental release of the chemical, for example, spillage of chemical on the lab bench. Section 7 advises on safe handling and storage methods. Section 8 on exposure controls and personal protection provides information on the exposure limits and extent of protection required when handling the chemical. For example, all lab users dealing with sulfuric acid has to put on safety goggles and protective gloves. Section 9 states the physical and chemical properties of the chemical. Section 10 covers the stability and reactivity of the chemical. Section 11 provides data on toxicology information, including effects of the short-term and long-term exposure to the chemical. Section 12 explains the effect of the chemical on the environment and ecology. Section 13 is important in providing guidance on how to handle and dispose the chemical safely. Section 14 is about how to transport the chemical safely. Section 15 talks about the regulatory information related to the chemical. And lastly, Section 16 provides other information relating to safety and health. Next question. Identify the GHS pictogram, signal word, and hazards associated with the use of sulfuric acid. Based on the SDS document, the GHS pictogram used is corrosive. Signal word is danger. Hazards include corrosive to metals, skin corrosion, and eye damage. What preventive measures can be adopted to minimize the hazards associated with the use of sulfuric acid? You can wear PPEs such as protective gloves, protective clothing, eye protection, and face protection. Now let us look at the last aspect of GHS, which is to design proper chemical product labeling to communicate the chemical hazard. GHS labeling applies to both the chemical supplier and the user. This means that, for example, if the lab user transfers the chemical from the original container to a new container, the new container should also contain the GHS label. A standardized labeling format is to be fixed onto the containers containing the hazardous chemical. There are 7 components, namely product name, GHS pictogram, signal word, hazard statement, precautionary statement, supplementary information, and supplier information. All this information can be obtained from the SDS of the chemical. Product name identifies what the chemical is. GHS pictogram conveys the physical, health, or environmental hazard assigned to the GHS class or category. Signal word indicates the severity of the hazard. Hazard statement describes the nature of the hazard. Precautionary statement includes the personal protection needed and emergency response measures in the case of an accident. It can include the general precaution, how to prevent incident, how to respond to an incident, how to safely store and dispose of the chemical. Supplementary information provides additional useful information on the chemicals. Lastly, supplier information typically includes the name, address, and phone number of the supplier. Okay, so here is an example showing the actual chemical product labeling. Product name in this case is epichlorohydrin. There are 4 pictograms associated with this chemical: flammable, toxicity, acute toxicity, and corrosive. The signal word being used is danger. Hazard statements, there are quite a few. So as you can see that it mentioned about this chemical is being flammable, toxic, and also corrosive. Precautionary statements, there are also quite a few. For example, wear protective gloves, protective clothing, eye protection, face protection because the substance is corrosive. Keep away from heat, sparks, open flames, hot surfaces. No smoking because it's flammable. Supplementary information. Container remains hazardous when empty. Continue to observe all precautions. For further information on this product, refer to manufacturer's SDS. And lastly, for supplier information, it indicates the supplier's name, address, and also the telephone contact number. There's also requirement on how big the chemical product labeling should be. The general rule of thumb is that larger bottles require larger labels. Here you will notice from the table that the smallest container is actually 125 ml. So are labels required for chemicals that are transferred and stored in containers less than 125 ml? The answer to the question is yes. We still need to label such containers, be it a bottle or a test tube. However, in this case, we can apply reduced workplace labeling because the container might be so small that we can't fit in all the information onto the label. So in this case, we only need to include the product name and the GHS pictogram. However, please take note that chemicals transferred to such container should only be sent for further research analysis within the same workplace. It should not be supplied to another workplace because the information is actually incomplete. In this segment, we'll learn about the proper handling of chemical hazard. Chemical safe practices include the following aspects: the safe handling and use of the chemicals, proper storage, transport, and disposal of the chemicals, and lastly, to apply the appropriate risk control measures. Chemicals shall be used as directed in process specifications and handled only by trained personnel, which means that before using any chemical, you should always be properly trained and read through the SDS document. If there is a change in the process, for example, if you want to scale up the experiment, always double check with your teacher first. Standard operation procedures must be in place for all tasks including receiving, handling, transporting, and disposal of chemicals, and they must be strictly followed with. When you are handling hazardous chemicals, you should do it in a chemical fume hood or other kind of a ventilation system to minimize the exposure to the hazardous fumes or vapors. Good housekeeping must be maintained in areas where the chemicals are used and stored. For example, during your experiment, always make sure the various containers containing the different chemicals are clearly labeled. Smoking, eating, and drinking shall not be permitted in areas where chemicals are stored or handled. Smoking is not allowed because in a lab there will be flammable substances. Eating and drinking can cause cross-contamination of the chemicals into your food and drinks. Suitable PPE must be worn while handling the chemicals. This refers to, but not limited to, your lab goggles, gloves, and lab coats. In case if there is a chemical spill involving concentrated chemicals or large volume of the chemicals, a trained emergency response team must be gathered to handle the chemical spills using the chemical spill kits. Now let us look at how to properly store the chemicals. Breakable chemical containers should be stored in a secondary container, also known as the secondary containment. This is to prevent any spill from the primary container. In this case, the primary container refers to the Durian bottle holding the chemicals, and the secondary container refers to the tray holding the Durian bottles. Primary container must be able to withstand a long-term exposure and also be non-reactive to the chemicals. For example, glass or plastic container. And the secondary container should be able to contain any spill from the primary container. All chemical containers should be dated when received or opened, and the chemical storage areas should be equipped with facilities for emergency response. For example, firefighting, spillage control, and first aid kit. When not in use, all chemicals should be locked away to keep away from the unauthorized persons. So only the authorized personnel will be holding on to the keys. Here are some of the general guidelines for the storage of chemicals. Do not store chemicals on the floor or on the laboratory bench tops, as they carry the risk of being walked into or knocked over. Chemicals should be stored within sight of reach and not above eye level, as chemicals can crush onto face. Chemicals shouldn't be stored in fume hood, as this can disrupt the airflow in the fume hood and cause vapor to travel back to the lab environment. Chemicals shouldn't be stored in excessive quantity. Always purchase chemicals to fit the storage capability. Do store chemicals away from source of heat, as heat can cause building up of vapor and pressure, leading to container rupturing. Containers also shouldn't be completely filled, they should leave a certain headspace. Store chemicals which are properly labeled, and store them by compatibility first, then by alphabetical order. Incompatible chemicals means that upon mixing, they can produce fire, explosion, or poisonous gases. So efforts must be made to ensure such mixtures do not occur. We can do so by storing chemicals into segregated cabinets, for example, flammable, toxic, and corrosive cabinets respectively. In the next few slides, we will take a look at the storage of a few specific chemical hazards. First of all, storing flammable chemicals. Flammable chemicals refers to chemicals which can catch fire easily. We need to protect them from ignition source and to store them in 1 hour fire-rated storage cabinet away from heat source or in a cool, well-ventilated area. 1 hour fire-rated cabinet means that the cabinet can resist the exposure of a standardized fire exposure for 1 hour. Do not store flammable with oxidizing chemicals or reactive chemical to moisture or air, for example, pyrophoric substances, as they can cause the ignition of the flammable substances. Next, storing corrosive chemicals. Corrosive chemicals has either a very low pH, for example, strong acid, or a very high pH, for instance, strong alkaline. When in contact with water or moisture, inhaling the corrosive vapor or mist can cause severe irritation or damage to the respiratory tract. Hence, we should store them in the designated corrosive cabinets. We should store them below the eye level to prevent any accidental splash onto the face or into the eyes in case of a spill. Also, they should be stored in a secondary container to minimize any spillage. Do not store acids and alkalines together, as these two can react violently when mixed and even cause explosion. It's a good practice to store acids and bases in different corrosive cabinets. If they cannot be stored in separate safety cabinets, at least they must be stored in separate compartments within the cabinet. Do not store acids with flammable chemicals, as most acids are actually oxidizers, and they could cause ignition of the flammable chemicals. Storing gaseous chemicals. Gaseous chemicals are usually compressed in gas cylinders, for example, compressed oxygen, nitrogen, carbon dioxide. They can pose both physical and chemical hazard. We should store gaseous chemicals in minimum quantities in upright position, with labels indicating whether the cylinder is full, in use, or empty respectively. Stationary gas cylinders should be secured with safety chains to prevent any movement or falling over. A falling cylinder can pose a physical hazard to the user. Do not store the cylinder near heat source, as this can cause the expansion of the gases and even lead to explosion. Do not store near potential physical damage. Do not roll or drag the gas cylinder, as this can cause damage to the cylinder, leading to leakage of the gases. Do not store incompatible gases together, for example, oxygen and fuel gas. Next, transporting chemicals. Incompatible materials shouldn't be transported on the same cart in case of any mixture or reaction. Open containers shouldn't be transported in case of any fallover or spill. And bottles should be transported on the cart or trolley with set rails and secondary containment which can contain a spill, as shown on the pictures on the left-hand side of the slide. Proper disposal of waste chemicals. All waste chemicals should be disposed in accordance to the regulations of the National Environmental Agency. Waste chemicals should be poured into the designated waste containers. They should never be disposed into the public sink. Each container of the liquid waste must be placed in secondary containment that can hold the contents of the waste container if it breaks. Never take a waste container out of its secondary containment. Contents of the waste bottle should be clearly written. For example, as shown in the picture here, solid chemical waste, organic waste, and aqueous waste bottles are clearly labeled. When a waste bottle is full, the contents will be emptied into a larger waste drum. In the lab, if the waste bottle is full, please promptly inform your lab instructor about it. Next, we shall learn about the risk control measures for chemical hazards. The diagram here shows the hierarchy of control applying to the management of chemical risks. From the most effective to the least effective, there are 5 levels, namely elimination, substitution, engineering controls, administrative controls, and personal protective equipment. In the next slide, we shall look at some of the examples for each level of control. Basically, when encountering any chemical hazard, the first question that we need to ask ourselves is that if the use of a particular hazardous chemical is absolutely necessary, can the experiment still go ahead without the use of that chemical? If the answer is yes, then definitely removing the hazardous chemical entirely is the most effective control. However, if removing it entirely is not possible, then we can go for the lower levels of the control. And in reality, we can use a combination of the different levels of the controls. At the level of elimination and substitution, we can substitute the chemical hazard with safer alternatives. For example, buying premixed chemical instead of directly mixing them. Engineering controls refers to physical changes to the workplace, which eliminates or reduces the hazard in a job or task. For example, we can change process to minimize contact with hazardous chemicals. We can isolate or enclose the process by using, for example, fume hoods. We can implement better ventilation system to minimize the exposure to the hazardous fumes of vapor. Under administrative and work practice controls, we can rotate the job assignments or to adjust work schedules so that no single worker will be overexposed to a hazardous chemical. Lastly, personal protective equipment is the most basic level of the risk control. Workers can use protection to reduce exposure to the risk factors. They can use, for example, chemical protective clothing, respiratory protection, gloves, and eye protection. To summarize this section, we are going to look at a tragic incident happened at UCLA. When watching the YouTube video, please identify what are the causes which have led to this incident. We have come to the end of topic 3. To summarize, under this topic, we have learned about the globally harmonized system of classification and labeling, in which we have learned about the chemical hazard identification, safety data sheet, and the chemical product labeling. We have also learned about the proper handling of the chemical hazards, which includes the general safe handling and use of the chemicals, proper chemical storage, transport, and disposal. And lastly, we have learned about the different levels of the risk control measures for the chemical hazards.